Okay, integration, page 1. Number 1A, write down a definite integral that gives the area of each of the following regions. So this part we're going to get acquainted with the notation for integration, okay, which is very important for finding integrations with the calculator. Okay, so basically, what does an integration look like? An integration has a long script S here, which stands for sum, but it is so stretched out it doesn't really look like an S anymore. And then you're going to put two numbers here, and there's a smaller number which goes down at the bottom and a larger number which goes at the top, and these are X values which tell you what are the left and right edge of the area that you're going to calculate. And then in between you put a function which is the curve which you're going to find the area between this curve and the x-axis. And then finally you kind of put a period to it and say this is the end of it. dx is basically how you end the sentence, and the x here is signifying, by the way, the variable that I'm integrating is x, and so that's my main variable. It's kind of like, you remember the notation for derivatives where we have dy dx? The x here in the bottom is basically saying, oh, the x variable is the one I'm taking the derivative for, and dx here for the integral is also telling us that we're taking the integral with respect to that variable. Okay, so once again, this is the left edge, this is the right edge, this is the top curve of the area you're going to find, and the rest of it is just kind of, frescura. Okay, so I am going to draw here, like here's the top curve, so this would be the x squared, right? And then you got the 0 and the 1, which is the left and the right edge, and basically what you're doing is you're finding the area and under the curve, between the curve and the x-axis. Okay, so let's look at some real examples and write the equations for it. Write down a definite integral that gives the area of each of the following regions. So this one here, the left edge is -2 and the right edge is 4. So pretty obvious that that means that this is going to be -2 and this is going to be 4, because the bottom number is the left edge and the top number is the right edge. In the middle, we're going to put the function. The function is simply 5. And then, last of all, we're going to end the sentence by putting dx, right? So that's the expression for this first, like, rectangular shape. And then this other one, the left edge is 0.5 and the right edge is 3.5. So we'll put 0.5 and 3.5 for the top and the bottom. And then the function is just going to be the top curve here. In this case, it's a straight diagonal line to -2x plus 8. And then we're going to end the sentence with dx. Okay? And then we're going to use the GDC to find the areas above. And I'm going to show you two ways to do this. Okay? One of the ways, which I don't like as much because it doesn't draw the picture for you and you can't really see that you're doing the correct thing, is you go into math. And then you go here where it says fn int, which is option 9. You can just press 9. And then it gives you this same expression. And then you just type everything in. And if you want to do it this way, it's fine. You can do it this way. And then you put x there. And then you hit enter. And it gives you the answer, 30. Okay? And I'm going to do the same thing again. This time I'm going to do it for this other expression. Now that I have it out here, I can just like replace, parts of it. I could just put 3.5 here. I could put 0.5 here. I can, for the expression here, I could put -2x plus 8. See, I don't even have to go to math to retrieve it anymore. And it's 12. Okay? Now let me show you how to do it. This is the way I like to do it because it'll actually draw the picture for you and you can confirm that you're doing everything correctly. I'll put the function here. I graph it. it looks the same except for the fact that this is cut off at -2 and 4. How do I cut it off? I'm going to do second calc integrate. Second calc integrate, which is 7. And then I'm going to give it the left edge and the right edge by typing in the lower limit, -2, enter. Oops. Let's try that again. Graph. Second calc integrate, number 7. And then it's going to ask me for the lower limit. I'm going to type -2, enter. And then I'm going to put, and then the upper limit, I'm going to type 4, enter. And it'll actually color it in so that it looks exactly like the picture you have there, and it'll tell me that the answer is 30. Okay? So I like this a little bit more because you can kind of confirm that it matches your picture. I'm going to put -2x plus 8 here. And then I'm going to put in 0.5 to 3.5 for my limits. And then I'm going to do second calc, number 7, which is integrate. And I'm going to put 0.5 for my lower limit, enter. And I'm going to put 3.5 for my upper limit. And it'll color in pretty much what's there, and you can see that the answer is 12 like I had there. Okay? Alright. Now that I've showed you both ways, you can use either way to do the rest of the problems, okay? So here are definite integrals. I'm going to make this a little bit bigger because I can't really read the numbers. So it's from 2 to 6, and the function is x plus 1. So I'm just going to go to math, and I'm going to retrieve the integral function. I'm going to fill it in. It's 2 to 6, and the function itself is x plus 1. And I'm going to put dx here, and the answer is 20. Okay, and then what about this next one? This one is math 9. I'm going to go from -2 to 0. -2 to 0. -0.5 x plus 4. And I'm going to fill in the x here. And the answer is 9. All right? Okay. Next one. For each of the following diagrams, write down the definite integral that represents the area of the shaded region and find the area of the shaded region. Okay. So for this one here, the important information is the function itself, which is the top part of the region you're finding the area for. The bottom part of the region is always going to be the x-axis, okay? The left edge is -2, and the right edge is 2. So I'm going to write the expression. It's going to go from -2 to 2. The smaller number is always at the bottom, or the lesser number. And then the function goes in the middle. And then you put dx at the end. Okay, so I'm going to do this one with graphing so that I can match the picture. X plus 1 squared plus 0.5. Graph. And then I'm going to integrate it from -2 to 2. -2 to 2. So I go second calc 7, and the lower limit is going to be -2, enter, and the upper limit is going to be +2, enter, and the answer is 11.3. 11.3333, but you can round it to 11.3. Okay, let's go to page 2. Okay, so here we have two more shapes. And so for this one here, the important numbers are negative 2.5 for the left edge. And we're just looking for the shaded region. So, and this is x cubed minus 4x. Sorry, that's so hard to read. And the right edge is 0. So let's fill that in. So negative 2.5 to 0, and the function is x cubed minus 4x dx. I'm just going to make sure that we're just looking for the shaded region. Yeah, the area of the shaded region. Okay. Now, in the calculator, they put parentheses around here just to like make sure that the dx isn't like mixed in there. Let's go ahead and figure this one out. We'll put x cubed minus 4x for the function, and then we're going to graph it. See if it looks the same. And then we're going to put in the limits negative 2.5 to 0. So we'll say second calc. Did that go? No. Let's try one more time. Second calc 7, and then we'll go from negative 2.5 to 0. Negative 2.5, oops, 2.5, enter, 0, enter. And now we can see I did something wrong. So this is why it's good to do this method, because you see I did the wrong limit, and I can see that because it colored in the wrong part. Now I can see that I did something dumb here. I said negative 2.5, but actually the left edge of this is negative 2, right? So now I'm going to erase this 2.5 here, and now I'm going to go back and redo this. And one thing that's kind of annoying is when you redo it, it doesn't erase it. So just to erase it, I'm going to regraph it. Okay. Oh, it doesn't erase it again. Okay. I don't know how to make this erase, but let me try it one more time. Okay. Second calc, and then I'll do 7, and then the lower limit this time is going to be negative 2 because that's the correct answer, and then the upper limit's going to be 0. Okay, and now it says 4. Okay, so the answer is 4. Okay, and unfortunately it did not erase it, but I know that it's correct because now it goes between negative 2 and 0. Okay, all right. Now let's do the last one here, which is going to be. Oh, and this one's a little bit tricky because it doesn't tell us the left and right limits. We need to figure that out from the graph. This is one where you definitely should graph it, because otherwise how are you going to figure out these points? You're going to have to go back and remember the quadratics unit, which some people maybe can and some people can't. Okay, but the easiest way to do it is just to graph it. So I'm going to graph this negative parentheses x plus 1 and x minus 3. And I am going to graph it. And after I graph it, I'm going to find the left edge and the right edge by looking for the x-intercepts. And the command to look for the x-intercepts is second calc 0. Do you remember that? So I'm going to use second calc 0 to find the left edge and the right edge of where it intersects with the x-axis. So second calc 0, which is number 2, and I'm going to put the left bound slightly to the left of the left x-intercept, enter, and then I'm going to put it slightly to the right of the x-intercept, enter, and then I'm going to guess, and the left edge appears to be negative 1, okay, and then I'm going to go find the right edge by repeating second calc 0 again. So now I'm going to put the left bound. It could be any place that's to the left of the second x-intercept, so you can even do it here. Okay, and then the right edge, we need to put the cursor to the right. And we can actually, like, if we put in a big number, we could put like 4 or something, and then it'll there, see? And so then we just hit guess. And so the other x-intercept is 3, 0, so we know that this is 3. Okay? And now, for those of you who remembered quadratics, you can actually find the 3 by finding the root here and finding the -1 here, but that is totally unnecessary. You can just do it with the calculator, and it's the same procedure as with any other curve. Okay? All right, so now we have this expression. We now know that the left edge is -1 and the right edge is 3. So we can put that in. And now we can find the area by doing second calc integral, which is option 7. And I'm going to put in the lower limit, which is -1. And I'm going to put in the upper limit, which is 3. And you can see that it colors it in perfectly, and the answer is 10.6666, also known as 10.67 or 10.7 if you're looking for 3 significant figures. At least give me 3. Okay? Number 2, in each of the following, write down the definite integral that represents the enclosed area, and then find the area. Okay, so these are a little bit more challenging because they don't show you the graph. All right? So write down the definite integral that represents the enclosed area, find the area. Okay, so first of all, part A, it says the things that enclose the area are the function y equals x squared, the x-axis, and the vertical lines x equals 2 and y equals x equals 4. So basically what this is saying is the top is a curve, x squared. The left edge is 2, the right edge is 4, and the x-axis is always the bottom. Okay, so I suggest graphing the function x squared, and then that'll help you figure out what exactly you're doing here. So we're going to have x squared, and we're going to graph it. And then what we're going to do is we're going to say, okay, I'm going to figure out where 2 and 4 are, and then I'm going to find the integral of the area in between 2 and 4. So I could do that by doing second calc, integrate 7, and I'm going to enter 2, enter 4, enter for the lower and the upper. And then, oh, do you see how it's a little bit more slanted than what I drew? But we got the idea, right? And it's basically 18.6666, so you might say that it's 18.67. And oh, let's write out the definite integral. The left edge is 2, the right edge is 4, the function is x squared, and that's all you write. Okay? What about the next one? So in the next one, we got the function, we got the x-axis, and we have the left and the right edge, so that's not too bad. -1 to 1, right? The lesser number goes in the bottom. And we have the function itself, and then we have the dx. And so we don't even need to necessarily graph this, but it's kind of interesting to graph it, especially when they don't give you a graph. So let's go ahead and type this new function in. It's 1 divided by 1 plus x squared. If you want to, you can use the math numerator denominator, vertical fraction, or you could just use enough parentheses. Always put parentheses around the numerator and denominator. I didn't put parentheses around this numerator because the numerator was just 1, but if you want to be safe, you could put parentheses around the 1 too. And I'm going to graph this. And then I'm going to integrate it between -1 and 1. A little lump there. And so I'm going to do second calc 7. And then I'm going to type in -1. And then +1. And the answer is 1.57. Okay? All right. Suspiciously looks like half a pi, doesn't it? Okay, last one. This looks similar to this one here that we just did up there, right? It's like got two binomials here. So if we were going to write this out, we would put the function in the middle. And then we're going to go between the vertical axis and the vertical line x equals 1. The vertical axis is another way of saying x equals 0, right? So we could go between 0 and 1. So let's go into y equals. And then we're going to type in this function, x minus 3, x plus 2. And then we're going to integrate. And we're going to integrate between 0. Yeah, you know how I said that it looked like the one we just did at the top? The graph looks like it too, right? And then I put 0 for the lower limit, and I put 1 for the upper limit. And the answer is 6.17. Okay? All right, and the next one. The next one, we have the function. And then it tells us the line y equals 0. The line y equals 0 is another way of writing the x-axis. So basically what they're saying is between the function and the x-axis. So once again, they did not tell us the left and the right edge. We need to figure that out by finding the x-intercepts. Basically, we're going to have a similar situation to what we had before. We're going to have the function, and then we're going to have the x-axis, and we need to figure out these 2 points by doing second calc 0, okay? So let's do that. First, this one we're definitely going to have to graph because of that. So we're going to graph it. So it's negative x squared plus 2x plus 15 graph. And we're going to find the x-intercepts first. Because the two borders that we're going to find the area between are this blue curve and the x-axis. So let's find the intersection points by doing second calc 0. And first we're going to put the left bound to the left of the left x-intercept. There we go, enter. And then we put it slightly to the right. Enter, and the guess, we just hit enter, and it's negative 3. Negative 3. Negative 3 is the left edge, and the right edge, we're going to just repeat second calc 0, option 2, and then we're just going to move the cursor over to the slightly to the left of the right x-intercept. We can just type in a number like 3, and then it'll move over there. And then we'll go to the right side. We'll take the cursor and we'll make it go to the right side of this other x-intercept. It's almost there. There we go. And we hit enter. And then the guess can be anything. And the answer is 5. Okay, so the left edge is negative 3. And the right edge is 5, and the function itself is negative x squared plus 2x plus 15. Okay, and so if we do second calc, integrate, number 7, we could just type in for the lower limit negative 3, and then for the right edge we put number 5, we put 5, and we get, it's going to color it in perfectly. And then we'll get that the answer is 85.3. It's actually 0.3333, but 3 significant figures, right? Okay, last one. Now, maybe we don't remember what this looks like. This was a long time ago that we did exponentials. 3 minus e second natural log to the x. Okay, and we're going to find the area between this curve and the vertical line x equals -1 and the x-axis. Okay, so basically we are going to have the vertical line x equals -1 slightly to the left of the y-axis, and then it's going to, the other point that we're going to, I'm going to just draw this curve here. So do you see how I've redrawn the curve here? X equals -1 would be this line here, right? So basically I want this area between x equals -1, which is this yellow line, between the yellow line, the red curve, and the x-axis, which I'm going to draw in blue here. Okay, so all these considered as borders, and the shape we're left with is here. So basically it's going to be between the left edge, x equals -1, and then this x-intercept here. We need to find out that x-intercept. So the way we find out that x-intercept is we do second count 0, right? So let's do that. The left, we just put the left bound slightly to the left of that x-intercept, and then we move the cursor with the right arrow slightly to the right of the x-intercept. That's good enough. And then we hit enter, and then we press enter again for guess, and the answer is 1.0986. The 86 will make the 9 round up to 1.10. So basically this point here is 1.10. So the integral we're going to do goes between -1 and 1.10. Let me rewrite that. It's kind of messy. 1.10. Still kind of messy. 1.10. Okay. And the inside is going to be 3 minus e to the x dx. So let's do that. We'll do second calc, integrate, number 7, and then the lower limit's -1, enter, and the right edge is going to be 1.10, which is just the same as 1.1 in the calculator. I've colored imperfectly, and my answer is 3.66. And we're done.